Who's Chance Tarver?
I'm keeping my own time so I can try to get on the leaderboard. So in the next 4.5 minutes, I'm going to try to give a crash course on DSP for next generation wireless systems. So where are we going? What we plan to see in 5G is not just faster broadband for our phones, but more connectivity. And so we'll have devices that are connected to the internet and all this data going up to the cloud. And so we'll have large sensor networks, Internet of Things, and even we can have devices in our bodies that are doing sensing of your vital signs. And of course, mobile broadband of over 100 gigabits per second. But one problem is there's a finite amount of spectrum. So many people have, many of you have seen this. This is an FCC band plan, and it's pretty crowded. So where do we put all of these devices? So we have all of these challenges. We have increasing densification with more devices, increased spectrum congestion, and to be able to do any of this ultra-wideband signaling, we have new waveforms that are stressing the physical layer. And so to enable all of this, we have to look at new spectrum resources like millimeter wave and terahertz wave, and we have to use new technologies such as massive MIMO. And to help assist with the ultra-wideband, we have to help the physical layer by using pre-distortion. So our unique approach is trying to do a synergy across all of these domains. And so we look at the algorithm side of things, but that algorithm insight informs how we create the architecture and vice versa. And then at Rice, we actually implement many of these ideas in actual test beds. So one example of this is multi-user MIMO. So with MIMO, what we do is we have hundreds of base station antennas simultaneously transmitting to tens of users. There's a problem with this though. If I have hundreds of antennas, all of a sudden I can have over 180 gigabits per second going into a central processor. And so there's no way that I can get all of this data in. And so something unique about our group compared to many others is we don't just look at the theoretical aspects of this, we look at how can we actually implement this. And so my colleague Kaipeng Lee actually defended this work last week, I think, where instead of doing this centralized processing, we break it up into multiple antenna clusters, each working on a partial problem. And so by doing this, we can alleviate the bottlenecks in the interconnection, and we get a more scalable system with only minor losses to performance. We're able to implement many of these ideas. So at Rice, we have a power project, Platform for Advanced Wireless Research, called ReNew. And so ReNew is a reconfigurable ecosystem for next generation end-to-end wireless. And so this is a next step on the massive MIMO work that has been done here at Rice. And so with this, we are collaborating with more than 28 private sector companies from US wireless industry to be able to test new ideas in actual hardware. And Rice has a long history of this, going back all the way to the warp board. And so the warp board was originally developed at Rice, and on that, massive MIMO systems were built, and now multiple startups have spun out, and we are creating a next generation massive MIMO array. Well, if I have hundreds of antennas, I'm going to have hundreds of problems in the nonlinearities of these power amplifiers. And so power amplifiers are devices that if I give it a small signal, it's going to amplify that signal into something bigger. Ideally, we'd like to see that just be a linear gain, but that's not really the case. And so we'd like to see something like this where the output power is growing linearly with the input power, but it'll start to saturate, and that nonlinearity will cause problems. And so if I'm trying to transmit maybe 10 megahertz LTE signal, after it goes through the nonlinearity of the power amplifier, I get the spectral regrowth around the main carrier. And so this is bad for coexistence, and it's not allowed by the FCC. So through digital pre-distortion, we can, on the fly, learn the unique nonlinearities of a power amplifier and pre-distort so that the cascade of our DPD and the power amplifier is linear. And so we're looking now and how do we expand this to systems with hundreds of power amplifiers for massive MIMO? How do we use this in systems where we have ultra-wide bandwidths, like in 5G, where maybe we have 100 megahertz downlink signals, and we're looking at how to use this to improve coexistence among devices. And so after we apply DPD, we can see that we have much reduced adjacent channel leakage ratio. And so all of this work is done with many partners, Christoph Suter at Cornell, Kaipeng, and Joe Cavallero, The Power and Renew testbed is a large project that involves Lin Zhang, Edward Knightley, Ashu Cyberwall, and all of this is helping us to enable this massive device-to-device connectivity and the unique approach at Rice of co-design between the DSP side of things, the architecture, and the testbed makes us very well suited to these sort of wireless problems. Thank you.
Not top of the leaderboard, but closest to the target. Closest to the target. 1 second off.